Hello everyone, this is the second video about lists. That is the second of my videos. I recommended you to watch 3 videos before that one, and with any hope you did. So now we are moving on to a more interesting topic, that is two-dimensional list. In other words, a list of lists. And as you can guess, you can nest them even more if you need to. And hopefully by the end of the video, you will see why it is good and important to be able to do that. So first of all, two-dimensional list, you can think of it as list of lists. So a list element of which each element of which is a list, or maybe some elements of which are lists. They don't have to be of the same length, but in some way you do want your data to be structured as much as practicable. So do not embark into creating like the most diverse lists possible. Those would be very hard to work with or parse. So you can think of a two-dimensional list as having rows and columns. So every element, for example, can be a new row, and that's actually how the lists are visualized. So every element of the list is a row, which is in turn actually a list. And to process data in two-dimensional lists, you need to work with two indexes and reference the elements into indexes. So you have rows, you have columns. Which one is the first, which one is the second is up to you. In this case, my guess is that, okay, so it's better to actually work with a specific problem. So scores 0, 0. Notice that in a row, the first element is the same. So in the way that we are referencing the lists, we have a little list that consists of all the row values. And those are indexed by the second index 0, 1, 2. And this list is actually an element or item of index 0 in the big list. Now, let me show that in example. So my list will be a list of lists, and first will be my name, and second element will be just numbers, so 3 and 4. Okay, so this is a list of lists and or nested lists. So the list L consists of two items. One item is a list consisting of my first name and last name, and the other item is a list consisting of numbers 3 and 4. So just to test this, let's try L0, and that will give me the first list in my list, the first item in my list, which is a list consisting of two elements. Very similarly, I can do L1. That is the second item on my list L, which is a list. Again, they don't have to be of the same length, but let's not look at more diversity than we are comfortable just yet. When you need a list consisting of lists of different length, you can create. And now I want to address specifically this element. For example, I want to return 3. First of all, on the big list L, this element, list consisting of 3 and 4, is index 1. So that is L1. And now we have addressed this list consisting of 3 and 4, and 3 has index 0. So here we go. Here is how we can address a specific element in the list. Why do we want to address it? For example, we can update it to a different value, like this. Let's make it 17 now. And let's print everything. Here we go. So that is a list of lists. And in order to be comfortable with a list of lists, you need to be aware of how to address list elements by their index. And you can do it in a loop. So let me restart the idle. All right, so I restarted the idle. My list for now consists only of 4 elements. It's a simple list. And this is what we did previously. This is the most basic way to iterate through a list. And whenever it works, it's fine. So it does work. Oops, sorry, I need to print X. Let me try again. I was going to print X, just X, not the whole list each time. Okay, here we go. Now there is another way to iterate through a list by iterating through the list indexes. Remember, there is a length of a list. In this case, it's 4, and that's what I'm going to use. So for I, that is index, in range length of L minus 1, actually length L, print Li. Now, notice what I did just now. Length L was 4, so for I in range 4, this is indexes running through 0, 1, 2, and 3, I'm printing the element Li. So what it will print is exactly the same, except for instead of iterating through the values directly, we're iterating through indexes. So for example, if I need to print the index 2, I can do that in this loop. So this is my index 0 and the element 10, index 1 and element 11. And first of all, I do know that there is a better way to do it with enumerate. So probably somebody also knows that, and they are commenting that I'm not doing it in the best way, but this is good enough for an example. And second, you may be wondering, why would you choose a more sophisticated code instead of the easier code? So as soon as you start working with lists of lists, you will begin to appreciate the need to extract a specific element and specific entry, and my upcoming example actually addresses that. And you do need to understand the correspondence between indexes and elements, and ability to iterate through the indexes and maybe select only some of the indexes if need be. And let me show you an easy example after I restart this. Here is my new example of a list of lists. Notice this is one row, this is second row, and this is the last row. So if you are familiar with matrices, you can think of this as a 3 by 3 matrix. If not, does not matter, it is a list of lists. And you can think of the elements of the big list as rows, and each of them consists of 3 numbers. Okay, for example, I want to, so since we think about 1, 2, 3 as a row, and 4, 5, 6 as a row in a square table, I want to print the last column, that is 3, 6, and 9. And I can do that in this way. For I in range length L1, capital L, print, and here is where you might want to stop and actually think what I'm doing here, what kind of value I'm getting over here, and what am I supposed to finish with in order to only print elements 3, 6, and 9. Okay, I'm assuming that you did stop and you did figure it out, so let us see if my answer is the same as yours. First of all, this was taking the length of a row of an element in the big list, which is a list in its own right. That's what this length L1 did, and this code will work presuming that the length is equal or no less than the length of the first element. Otherwise, we might have trouble, but in this case, the length is always the same. I just did not want to write 3 because that would not generalize well to other examples. Okay, so print, I need from every row, print the last one. So how would I do that? Actually, I can simplify this and just say L here because we are iterating through the rows. Okay, that is simpler. So now I'm just gauging the length of this list of lists. It consists of 3 elements as well. So L, so ith row, where I will be values 0, 1, and 2. And in every one of them, I need second element. And here we go. So I printed 3, 6, and 9. There is an alternative way to do that. Instead of 2 to print the last one, I can do -1, and that will do the trick just as well. So sometimes, very often, you need to iterate through values using a list. And this is one of the ways to do that. We'll iterate through a list using indexes. All right, and now I'm ready to show you my example. Again, it's a wonderful idea after you read and understand the problem, after I introduce the problem, try to do it yourself. So create a program that will maintain the list of items, each of which consists of a list consisting of first name, last name, and age of a person. The program should be able to append records and return records. Maybe I'll say print all last names because that's where I decided later to go with. Print all last names. Okay, so just for example, a list of lists. Here is my list consisting of how many elements? 2 elements, 1 element, which is a list of length 3, and the other element, which is a list of length 3. Now I leave writing these functions as a challenge for anyone who feels up to it, but the way it should work really is described in the main. So this is reminding you about your top-down approach, and if you don't see any similarities with the final project that you will be submitting soon, then think again about this main. So action, input, choose action, add or print to print last names only, or quit. And here is a while loop, while action is not quit. What I'm doing here, actually, I don't need to prime it like that. I can prime it by just about anything except quit. So let's prime it with an empty string. Okay, action. While action is not quit, this priming will allow it to enter the loop. My action is input, choose an action, add, print, or quit. If the action is add, I'm gonna call add person, the function add person that you want to write. Else, if the action is print, you write another function. So the choice of these two functions, choice to make only these two things happen, is arbitrary. You could add much more functionality here and make it much better, but it's up to you. I'm handling the quit case, and finally the else. Whatever else the user inputs, you just print not a valid choice. So Try to do this using append and then using some comprehension of list indexes, print last names only. So for this very list, I would want to have this one and that one. Other things that could be useful, saving these lists, and we will return to saving data a little later using Pickle. But in any case, you know how to do it as a txt file. If you want to have additional experience, you can also write a function for saving it and also include that in the options that we have. Okay, stop the video, try it yourself. All right, my main is exactly the same as before. Feel free to stop and examine it. And now I wrote two functions, add person and also print last names. So let us debug them one by one. As you write a function, you need to be able to debug it. Test it, debug it. So I'm trying to call add person. And to the first name, I'm gonna enter my first and last name and my age. And now I want to print out people. Here we go. So to the existing data, I appended another item. An item is a list consisting of three constants: Vlad, last name, and age. First name, last name, and age. And this is numeric, so notice that in my program, I converted the age to int to be consistent with the data that I had. That is something that is easy to overlook. So my add person seems to be working. Now, how does it work? I ask for first name, last name, and age. Each of them is a separate input. And then I create a new item, which is a list of length 3. In brackets, I list f name, l name, and age, 3 variables, and I'm creating a new item. Finally, I'm using .append to add this new item. Now, what is interesting and important over here, I'm using a method, crucial for everyone. I'm using a method, and method actually updates the actual list people, not some obscure variable, local variable. So when you are using a method, you are actually updating the variable in the big program. And you can update a global variable. Okay, so that's what I did with add person, and now there is a short but important print last names. So people I 1 with indexes I and 1. Let us concentrate on this. People I, that references the item on the list. So this, for example, would be people 0. This would be people 1, and whatever I added will be people 2. And the second index 1 is actually the positional index for the last name. That's how my data structure is designed. So this is what will be printed for every entry in my list, for every item in my list. The second item in this list item will be printed. So let us test that it is actually working. Okay, people, just out of curiosity, we can print something this way, and now we can print last names, and this should print only last names, and indeed it does. So this is how you can work with list of lists, and for that you need to be comfortable with iterating through indexes. If you like a good example to do, there is an example which is called Magic Square. In the end of the chapter, something like problem 15, it's a big problem, you'll see it. And it's a good exercise that will make you write code like this. Um, you will sum values instead of just printing them, but if you do that exercise, you definitely understand how the list indexing works and how you can iterate through it.